Foundations of Amateur Radio. Every person is the product of their environment. Unsurprisingly, this is even true for radio amateurs. That's not to say that we can't break our mould, but it takes effort. I grew up around technology in the 1980s. As a result, I'm familiar with 8-bit microprocessors like the Motorola 6502, which featured heavily at the time. I tend to think in terms of the presence or absence of a signal rather than the intricacies of circuits and components. As a child of my time, I'm not particularly familiar with the punch card or paper tape, or core memory, or valves, 386 machine code, or what's in an FPGA. As a direct result of my age, my knowledge and understanding of circuits is sparse at best. I understand basic components like resistors and capacitors in a DC setting, Ohm's Law and the fun you can have with a battery, a few resistors, diodes and an LED light. As a radio amateur, I've been introduced to how some things work differently in an AC circuit, like an antenna and a feed line. Until very recently, my knowledge about filters was based on what I'd read. I know that there is fun to be had with coax and stubs and other cute things, but how and why they work eluded me. Today I'm a step closer. Before I dig in and share some of what I've learned, let's have a quick look at what a filter is and does. You'll have likely heard of high-pass and low-pass filters. You might have heard of band-pass and band-stop filters. If you think of a high-pass filter as a device that lets through high frequencies, and a low-pass filter as a device that lets through low frequencies, we're already well on our way. If you put a high-pass filter together with a low-pass filter, you end up with a range of frequencies that doesn't pass, known as a band-stop filter. Similarly, if you tweak the frequencies that pass just so, you can combine a high-pass and a low-pass filter to make a band-pass filter. Let me illustrate. Imagine a 15-meter bandpass filter. It allows all frequencies in the 15-meter amateur band through, but blocks everything else. You could construct such a thing from a high-pass filter that allows 15 meters and above through, combined with a low-pass filter that allows 15 meters and below through. Everything below 15 meters is stopped by the high-pass filter, and everything above 15 meters is stopped by the low-pass filter. The gap between the overlap of the high-pass and the low-pass filters is what creates a space where the 15-meter band gets through. If you move things around a little, the same can be constructed to make a 15-meter band stop filter, something that lets anything through except a 15-meter amateur signal. To make such a gadget would require a low-pass filter that allows everything below 15 meters, combined with a high-pass filter that lets everything above 15 meters through. So, if you can construct a high-pass filter and a low-pass filter, you can pretty much create any combination and allow or stop specific frequency ranges. If you're wondering why this might be useful, think about a contest. Two radios in the same shack, one transmitting on 15 meters and one on 40 meters. These two bands, one at 21 MHz and one at 7 MHz, are third harmonics to each other. This means essentially that a radio on 40 meters affects one on 15 meters and vice versa. If you had a set of filters that stopped 15 meters and passed 40 meters on one transceiver, and a set of filters that stopped 40 meters and passed 15 meters on the other, both of you would be much happier. You don't need to do contesting to benefit from a filter. If you use an RTL SDR dongle, it's affected by nearby strong signals, like say a local radio or television station. That's fine if that's what you're trying to hear, but not so much if you're trying to hear something else. Filters can help make your life better. Now, to round this off at a suitable point, you can think of an inductor as a device that lets low frequencies through but blocks high frequencies. Similarly, a capacitor is a device that blocks low frequencies but lets high frequencies through. So it's fair to think of an inductor as a low-pass filter and a capacitor as a high-pass filter. The symbol for a capacitor is the letter C, Charlie, and for an inductor it's the letter L, Lima. You could make a circuit that either directly blocks from a certain frequency or one that lets it through but sends it to ground. This gives you two designs for a low-pass filter, one using an inductor or an RL circuit, and one using a capacitor or an RC circuit. Similarly, you can create a high-pass filter using either an inductor or a capacitor. That gives you 4 designs for 2 filters. Each of these can be combined to create band-pass and band-stop filters. The maths behind it isn't particularly daunting with basic high school maths, and if you want to see it happen before your eyes, check out the Organic Chemistry Tutor on YouTube. The playlist you're looking for is cleverly disguised as electronic circuits. As a direct result, I started hunting for breadboards, but it turns out that you can simulate these circuits online using any number of simulators. Of course, there's going to be a gap between simulation and reality, but that's when you get out your soldering iron. Remember, if you smell chicken, you're holding it wrong. I'm Onno, Victor Kilo 6, Foxtrot Lima Alpha Bravo.